Polynomial equations with real roots. In the preceding examples, what we should have observed about the roots is that when the coefficients of the equation are all real, the roots occur as a conjugate pair, or at least the complex roots occur as a conjugate pair. When the coefficients are not real, we cannot guarantee this. However, when solving equations with real coefficients, we can use this fact. If we know one complex root, then another complex root must be the conjugate of the root we know. If we are solving a cubic equation with real coefficients, we may have the following situations. Three distinct real roots. So if we actually sketch something like that, we've got a graph here, and we have this type of shape for our cubic. We can see that we do have roots here, here, and here. So that would be three distinct real roots. Two real coincident roots and a third distinct root. So what might that look like? So that might look something like this, where we've got one root here and then a turning point actually on the axis. And of course these are all real roots. Three coincident real roots. So what might that look like? Well, that might look like just y equals x cubed, where we know that we have the point of inflection just here. And then we may have one real root and a complex conjugate pair. Now if you think about the shape of a cubic, where it goes off the bottom of the graph and off the top, either here, or if it's shaped like this, off the top on this side and off the bottom on that side, it's got to cross the x-axis somewhere. But it only needs to cross once. So in this case, we have the one real root, and it doesn't cross again, so the other two roots would be complex. Note, it is not possible for a cubic equation to have no real roots. If you think about the shape of the graph, it has to cross the axis somewhere, and that's what we discussed just over here. It's got to cross at least once. Now here we've got some slightly better pictures of what we drew over here. So on this one we can clearly see the three distinct real roots. Here we have a distinct real root and then two coincident real roots where it just touches the axis. This one here only has the one real root just here, and this one here has a point of inflection that's actually on the axis, and we consider that to be three real roots. For a point of inflection, we consider that it crosses the axis, crosses back, and then crosses back again, all at the same point. So that's three roots which are all the same. When solving a cubic or higher order equation, we can use the factor theorem to find one or more roots. Now usually when solving a cubic, we just find one. If it's a higher order equation, we may use the factor theorem to try to find more of the roots. And the aim is that we leave ourselves with a quadratic. Then we can solve the remaining quadratic either by factorization, the formula, or completing the square.